The universe has always whispered secrets in the quiet corners of observatories, secrets that could unravel the very fabric of our existence. For years, the James Webb Space Telescope, a marvel of human ingenuity, has been peering into the cosmic abyss, its golden mirrors capturing light from the dawn of time. It's been a hushed rumor among scientists, a tantalizing possibility that this telescope might, just might, have the power to sniff out signs of life beyond our pale blue dot. And now a seismic shockwave is ripping through the scientific world, a revelation so staggering it could rewrite history. The James Webb Space Telescope may have detected alien life on a distant exoplanet called K2-18b. This isn't just another space story. This is the story, the one that could change everything we thought we knew about our place in the cosmos. Buckle up, because what's unfolding is nothing short of mind-blowing. Picture this: a planet 124 light-years away, a world so distant that its light takes over a century to reach us. K2-18b is no ordinary rock. It's a sub-Neptune, about 2.6 times the size of Earth, and 8.6 times as massive. It's a behemoth, orbiting a red dwarf star in a tight 33-day loop, basking in its star's habitable zone, where conditions could allow liquid water to exist. That's the cosmic sweet spot, the Goldilocks zone where life as we know it might, just might, take root. This planet isn't some barren lump of rock or a gas giant swirling with storms. It's a candidate for something extraordinary, a water world, a so-called Hycean planet, draped in oceans beneath a hydrogen-rich atmosphere. Imagine endless seas stretching to the horizon, no land in sight. A planet where life, if it exists, would be aquatic, alien, and utterly unlike anything we've ever seen. The story begins with a whisper in 2019, when astronomers first detected water vapor in K2-18b's atmosphere. Water vapor. That alone sent pulses racing. It suggested this could be an oceanic world, a planet where waves crash under alien skies. Fast forward to 2023, and the James Webb Space Telescope turned its unblinking eye on this distant world, revealing something even more tantalizing: carbon dioxide and methane in the atmosphere. These gases are linked to life on Earth, though they can form without it. But then, a bombshell dropped. Webb detected a gas called dimethyl sulfide, a molecule so shocking it sent the scientific community into a frenzy. Why? Because as far as we know, dimethyl sulfide is produced only by life, specifically by marine phytoplankton, those microscopic ocean dwellers that churn out this gas as they thrive. On Earth, it's the smell of the sea, a whiff of life itself. Could K2-18b be teeming with alien microbes, pumping out this gas in a cosmic symphony of biology? But here's where the plot thickens. That first detection in 2023 was faint, like a whisper in a storm. Skeptics raised their eyebrows, calling it noise, a glitch in the data. The signal was weak, barely a flicker. Scientists needed more. So they went back to Webb, this time using a different instrument, the MIRI spectrograph, to double-check. And what they found is nothing short of jaw-dropping. The detection is now at 3 sigma, statistically significant, with only a 0.3% chance of being a fluke. That's not just a flicker anymore, it's a beacon. The data suggests not just dimethyl sulfide, but possibly dimethyl disulfide, another gas tied to biology. Both are thought to be unique to life, and both were detected independently, with different instruments, boosting confidence that this isn't some cosmic mirage. Let's pause for a moment to let that sink in. A telescope, floating a million miles from Earth, may have caught the scent of alien life. This isn't science fiction. This is happening right now in our lifetime. The implications are staggering, heart-stopping, universe-shattering. If this holds up, it's not just a discovery, it's a revolution. It means we're not alone. It means life, at least microbial life, could be out there thriving on a distant ocean world. It means the universe might be brimming with biology and we're just scratching the surface. But caution is the watchword. Science doesn't leap to conclusions, no matter how tempting. Extraordinary claims demand extraordinary evidence, and the gold standard is a 5 sigma detection, a mere 0.006% chance of error. That's the level where scientists pop the champagne. The team believes they're close, that more time with Webb could push this over the finish line, but even at 3 sigma, the signal is strong enough to make hearts race. The scientific community is buzzing, and the media is ablaze with speculation. Could this be it? The moment we've been waiting for since we first looked up at the stars? Now let's dive into the weirdness, because K2-18b is an alien world in every sense. Its atmosphere has 20 times more dimethyl sulfide than Earth's. 20 times! That's not a typo. Whatever's producing this gas is doing it on a colossal scale, replenishing it constantly because dimethyl sulfide doesn't linger long in atmospheres. It's a short-lived molecule, so something, whether life or some unknown process, is pumping it out in massive quantities. On Earth, phytoplankton produce this gas in tiny amounts, but K2-18b is like a cosmic factory, churning out this biological signature in concentrations that boggle the mind. And here's the kicker. Theoretical models of Hycean worlds predicted exactly this. They suggested that life on such planets would produce high levels of these gases, and K2-18b is ticking every box. But there's a twist. Some scientists are waving a red flag. Could these gases form without life? Is there some exotic chemical process we've never seen? Some quirk of planetary chemistry mimicking a biosignature? It's possible, though unlikely. Dimethyl sulfide and disulfide are stubbornly tied to biology on Earth, and no known abiotic process produces them in such quantities. Still, the skeptics have a point. K2-18b is a strange world, with crushing gravity 8.6 times Earth's. That kind of pull could calm oceans, stifle complex life, and make the environment hostile to anything beyond microbes. If life exists here, it's likely simple. Alien bacteria or phytoplankton-like organisms, not little green men or intelligent civilizations. But even that would be monumental. Microbial life on another planet would prove that abiogenesis, the spark of life from non-life, isn't a one-off fluke confined to Earth. Let's talk about the planet itself. K2-18b orbits a red dwarf, a type of star that's smaller and cooler than our Sun, but far more common, making up 73% of the Milky Way's stellar population. Red dwarfs have been a hot topic in the search for life because their habitable zones are close in, meaning planets that are tidally locked. One side, eternally facing the star, the other, shrouded in darkness. For years, scientists debated whether red dwarfs could host life. Young red dwarfs are volatile, spitting flares that could strip atmospheres from nearby planets. Early data from Webb's observations of the TRAPPIST-1 system seem to confirm this, with its inner planets appearing barren. But K2-18b is different. It has an atmosphere, a thick one, rich with water vapor, carbon dioxide, methane, and now possibly biosignatures. This could be a game changer, proving that red dwarfs, despite their fiery tempers, can nurture life. If this detection holds, it's a cosmic bombshell. It means the most common stars in the universe are habitable. And since 80% of red dwarfs are thought to have planets in their habitable zones, the galaxy could be teeming with life. Imagine that for a second. A universe where microbial life is as common as stars, where oceans on distant worlds pulse with alien biology. K2-18b, just 124 light-years away, could be the first domino to fall, revealing a cosmos alive with possibility. But there's a bittersweet edge to this story, a shadow cast by the planet's nature. K2-18b's high gravity and oceanic makeup raise tough questions. If it's a Hycean world, it's likely all ocean, with no land to speak of. Life there would be aquatic, locked in a deep, sunless sea. On Earth, phytoplankton thrive near the surface, soaking up sunlight. But K2-18b's life, if it exists, might dwell in darker depths, relying on chemical energy from hydrothermal vents, rather than photosynthesis. That's a very different kind of life, one that might never evolve into anything complex. And that gravity, 8.6 times Earth's, would crush any hope of advanced civilizations. Even if intelligent life emerged, it would be trapped. Chemical rockets couldn't escape that gravitational pull. No satellites, no space travel, no signals beaming into the void. If K2-18b is inhabited, its life is likely silent, locked in its watery prison. This brings us to a haunting possibility: the Fermi paradox. The question of why we haven't seen signs of intelligent life despite the universe's vastness. If Hycean worlds like K2-18b are common, they might be the norm for life-bearing planets. Deep oceans, high gravity, no land. Intelligent life could exist, but it would be trapped, unable to smelt metals, build telescopes, or launch probes. The universe might be full of minds, but they're locked in their worlds, unable to reach out. It's a lonely vision, a cosmos where life is everywhere but civilizations are rare. If we ever venture to the stars, we might find ourselves as cosmic rescuers, uplifting these trapped intelligences, helping them escape their watery cages. But that's a dream for the distant future. For now, the focus is on K2-18b and what it means for us. If this detection is confirmed, it's a triumph for the James Webb Space Telescope, a testament to human curiosity and engineering. Webb's ability to analyze exoplanet atmospheres is unparalleled, and this could be its crowning achievement. A 5 Sigma detection would likely earn Nobel Prizes, cementing Webb's legacy as the telescope that found alien life. But even if the signal is disproved, we'll learn something profound. If dimethyl sulfide isn't a biosignature, it means there's unknown chemistry at play, a new piece of the cosmic puzzle. Either way, we win. We push the boundaries of knowledge, inching closer to answering the ultimate question. Are we alone? Let's dream for a moment about what's next. If K2-18b's biosignature is real, it opens the door to more discoveries. Future telescopes, even bigger than Webb, could directly image the planet, searching for a red edge, a spectral signature of vegetation that reflects infrared light. On Earth, this comes from plants, but on K2-18b, it might come from alien phytoplankton or something entirely new. Webb can't do this. It relies on transits, catching the planet's atmosphere as it filters starlight. But a next-generation observatory might peer straight at K2-18b, revealing its secrets in vivid detail. And if life exists here, it raises another question. How did it start? On Earth, we're still debating whether life began in oceanic vents or volcanic hot springs. K2-18b, with its deep oceans, suggests vents might be the cradle of life, meaning our biogenesis could have multiple pathways. If that's true, life might be even more common than we dared hope. Now let's get emotional, because this isn't just about science, it's about us. For centuries, we've looked at the stars and wondered. We've written poems, built myths, and launched probes, all driven by a burning need to know if we're alone. K2-18b is a mirror reflecting our deepest hopes and fears. If life exists there, it's a second Genesis, proof that the universe isn't a cold, empty void, but a place where life can spark again and again. It's a reminder of how fragile and precious our own world is, a call to protect the only home we know. But it's also a challenge. If the universe is alive, what's our role? Are we explorers, stewards, or something more? The discovery of alien life would force us to confront our place in the cosmos, to rethink what it means to be human. And yet, there's a pang of sadness. If K2-18b's life is trapped, it's a poignant reminder of our own limits. We're bound to Earth, at least for now, our dreams of the stars tempered by the realities of physics. But every discovery, every signal from a distant world brings us closer to breaking free. K2-18b isn't just a planet, it's a beacon, a signpost in the vastness, urging us to keep looking, keep searching, keep dreaming. It's a call to the next generation of scientists, poets, and explorers to pick up the torch and carry it forward. As we stand on the brink of this potential discovery, the air is thick with anticipation. The James Webb Space Telescope has given us a glimpse of something extraordinary, a hint of life in the cosmic ocean. Whether it's confirmed or debunked, this moment is a turning point. It's a reminder that we're living in a golden age of exploration, where each new observation pushes the boundaries of what's possible. K2-18b is more than a planet. It's a symbol of our relentless curiosity, our unyielding desire to know the unknown. So let's hold our breath, keep our eyes on the stars, and wait for the next chapter in this cosmic saga. The universe is speaking, and we're finally learning to listen. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up